Section 9.7 is on solving a system of linear equations in 3 variables and finding quadratic functions. So first we want to talk about what a linear equation in 3 variables would look like, since we talked about a bunch of different types of equations already in this course. In chapters 1 through 6, we worked with linear equations in 1 or 2 variables, and now we're going to be working with 1 and 3. In one variable, something like maybe 2x plus 5 equals negative 12. Okay, a linear equation in 2 variables, something like 2x minus 7y equals 1. And a linear equation in 3 variables is something like 2x plus 8y minus z equals 4. Okay, so unlike the rest of this chapter, where we've been primarily working with quadratic equations, equations that have exponent 2, these are all going to be linear, so it's going to have 3 variables. Recall that a solution to a linear equation in 2 variables is an ordered pair, x comma y. The solution to a linear equation in 3 variables is an ordered triple, x comma y comma z. Decide whether the ordered triple is a solution to the equation 2x plus y minus 3z equals 7. Okay, so all we need to do is plug in the values of x, y, and z for the variables and see if 7 is the answer or not. So in the first one, we have 2 times 4 plus 5 minus 3 times 2, and we want to know, is this equal to 7? So this gives us 8 plus 5 minus 6. 8 plus 5 is 13 minus 6 is 7. So this one is yes, that ordered pair 4, 5, 2 is a solution to this equation. Let's check out part B. This one is 2 times 3 plus negative 2 minus 3 times negative 1. We want to know, is this equal to 7? So this is 6 minus 2 plus 3. 6 minus 2 is 4, plus 3 is 7. So this ordered triple also is a solution to the equation. In example 2, we want to assume that the ordered triple 2, y, 5 is a solution, and we want to find the missing coordinate. So we don't know the value of y. We know what value of y makes this ordered triple a solution. So we have 2 times the x value 2 minus 3 times the y value. The y value is unknown, so we'll leave it as a y, plus the z value is 5. If I know 2 of the coordinates, I can solve for the third one. This is 4 minus 3y plus 5 equals negative 9. 4 plus 5 is 9. Minus 3y equals negative 9. Subtract 9 from both sides. Negative 3y equals negative 18. Divide both sides by negative 3. And we get y equals 6. So the ordered triple is 2, 6, 5. The ordered triple 2, 6, 5 is a solution to the equation. Alright, now before we can start working with our equations in 3 variables, we need to recall how do you solve an equation in 2 variables. So we're going to recall the elimination technique from chapter 6. In the elimination technique, you want to multiply one or both equations by something and then add the 2 equations together to eliminate a variable. So if you look at your x's, 3 and 5 both go into 15. If you look at your y's, 3 and 6 both go into 6. Since 6 is a smaller choice, it's smaller than 15, we're going to choose to eliminate y. Now, this one's already a 6. This one's a 3, and if you multiply it by 2, you'll get a 6. So we're going to choose to multiply it by 2, but we're going to make it a negative 2 so that one of our 6's is positive and the other one is negative. So we're going to multiply the entire first equation by negative 2. That gives us 10x minus 6y equals 18. Now, the second equation doesn't need to be multiplied by anything since it already has a 6y. So just multiply it by 1. You're going to get 3x plus 6y equals 21. Now you're going to add the 2 equations together, and because the negative 6 and positive 6 are going to add to 0, we call this eliminating from the elimination method here. And we end up with 10x plus 3x is 13x equal to 18 plus 21 is 39. And I can solve this now for x. Divide both sides by 13, x equals 3. X equals 3 is only part of our answer. Don't forget that this was a 2 variable system, so we need to find the y coordinate as well. So take either one of the equations, it does not matter, and plug the x value in, and we'll solve for the y value. So I'm going to work with the second equation. So I'm going to have 3 times 3 plus 6y equals 21. So that's 9 plus 6y equals 21. Subtract 9 from both sides. So 21 minus 9 is 12. So if I divide both sides by 6, I get y value is 2. The complete solution is the ordered pair, in this case 3, 2. That would be the solution to this equation. I wanted to recall the method of solving 2 variables because the method for solving 3 variables is based off of that. I'm also going to do elimination. What I want to do first is take a pair of equations and eliminate a single variable, then take 2 other equations and eliminate the same variable. If I eliminate one of my variables, it's going to be left with the 2 variable situation. So now I'm going to have a 2 variable case that I can solve with substitution or elimination. Okay, once I solve one of those equations, I'm going to be able to plug the values back in to the equations until I find the value for my ordered triple. Alright, so let's check out an example. Examine all of your variables. X, the coefficients are 2, 1, and 3. Y, the coefficients are 3, 5, and 1. And Z, the coefficients are 1, 5, and 3. So overall, the one that has the most convenient coefficients, the smallest coefficients, are going to be the x's. So in our first example, we're going to eliminate the x's. So 2 equations at a time. I'm going to work with the top 2 equations first. And if I want to eliminate the x's, I want them to have opposite coefficients. So 2x and 1x both go into 2. I'm going to want 2x and negative 2. So I'm going to multiply the second equation by negative 2. The first equation is going to not change. It's just going to say 2x minus 3y plus z equals 2. And the second equation is going to become negative 2x plus 10y minus 10z equals negative 6. Add these equations together, eliminating the x's. Negative 3y plus 10y is 7y. Z minus 10z is negative 9z. And 2 minus 6 is negative 4. So eliminating the x's gave me a 2-variable equation in just y and z. Now I want to eliminate the x's again in 2 other of the equations. I can either choose the equation that has 2x and 3x, or the equation that has x and 3x. I'm going to choose the simplest coefficients, so I'm going to choose these 2. 1 and 3 have the least common denominator of 3, whereas 2 and 3 would have to have 6. So I'm going to use the bottom 2. So if I use the bottom 2 equations, we're going to need to multiply the second equation by a negative 3 this time to have a negative 3 and a positive 3 adding to 0. So let's multiply a negative 3 through everything. It's going to be negative 3x plus 15y minus 15z equals negative 9. Add that to the bottom equation, which was 3x plus y minus 3z equals 5. When you add them up, the x's are going to eliminate. And that's going to give us 15y plus y is 16y. And 15z minus 3z is minus 18z. And then the negative 9 plus 5 is negative 4. We now have 2 equations that are both in y and z, so we need to solve these 2 equations together. You can use either substitution or elimination because it's a 2-variable system. Elimination is going to be the best method in this one since all the coefficients are not 1. Okay, so looking at your y's and your z's, I need a number that both 16 and 7 go into, or a number that both 18 and 9 go into. It's going to be more convenient to work with the 18 and 9 since they both go into 18. So we're going to want to use 18. This one already has a negative 18, so let's make this one a positive 18. So we're going to take this equation and multiply everything by negative 2 to get to be a positive 18. So my top equation won't change. That's going to be 16y minus 18z equals negative 4. Multiply everything in the other equation by negative 2. So I'm going to get negative 14y plus 18z equals positive 8. Add those equations up. The z's eliminate, and 16y minus 14y is 2y. Negative 4 plus 8 is positive 4. So if you divide both sides by 2, you're going to get y equals 2. We have one of our variables completely solved for now. Now we need to go back and find what x and z are equal to if y is 2. The first thing you're going to do is plug it into one of the two variable equations. It doesn't matter which. I'm going to go ahead and pick the one that has the smallest coefficient, so this blue one. So it was 7y, which I now know is 2, minus 9z equals negative 4. So we're going to solve for our z value. So we have 14 minus 9z equals negative 4. Subtract 14 from both sides. That's negative 9z equals negative 18. Divide by negative 9. We're going to get a z value of positive 2. Now I know two of my variables. Y is 2 and z is 2. So we're going to use one of the original equations, it doesn't matter which, to solve for x. Let's just go ahead and use the top one. So 2x minus 3y plus z equals 2. That's going to be 2x minus 3y, 3 times 2, plus z equals 2, plus z is 2 equals 2. So we've got 2x minus 6 plus 2 equals 2. That's 2x minus 4 equals 2. Add your 4 to both sides. 2x equals 6, and so if you divide by 2, you get x equals 3. That's your third variable. So the solution has x equals 3, y equals 2, and z equals 2. So the answer to this system is the ordered triple, 3, 2, 2. We've got our x value, our y value, and our z value. Let's do another example. In this system, some of the equations are missing variables. So for example, I have 2x minus y and 0z equals negative 8, and y plus 3z equals 22. This one has no x. And x minus z, this one has no y, equals negative 8. I don't have any two equations that have the same variable, so I'm going to take two of them and eliminate a single variable and probably use it with a third. So let me show you what I'm talking about. If I look at the first and second equation, I notice that I have a negative y and a positive y, so I'm going to be able to eliminate them. I don't need to multiply by anything, they're already set up. So we've got 2x minus y equals negative 8, and y plus 3z equals 22. If I add these two equations together, the y's are going to eliminate. It's going to give us the equation 2x plus 3z equals 14. This equation has just the letters x and z, and so does the bottom equation, just the letters x and z. So we're going to be able to use these two equations together. If I want to eliminate the x's, I can multiply this equation by negative 2. If I want to eliminate the z's, I can multiply this equation by positive 3. Let me go ahead and multiply it by positive 3 so that my z's are already set up to eliminate. Okay, so this equation is going to become 3x minus 3z equals negative 24. And my other equation was 2x plus 3z equals 14. When I add these two equations together, I get 5x, the z's eliminate, equals negative 10. So if I divide both sides by 5, I get x equals negative 2. Okay, now that I know that x is negative 2, I can plug it into any equation that contains x and a single other variable to find another variable. I'm going to go ahead and plug it into this equation to find my z value. So x minus z is negative 8. So negative 2 minus z is negative 8. Be careful with my handwriting because my 2's and z's are similar, so I cross my z's here. Add 2 to both sides. Negative z equals negative 6, and if I divide by negative 1, I'll find that z is 6. Now I need to use an equation that has y to find y. It doesn't matter which one. Let's go ahead and use the top one, and I'll show you that it doesn't matter by using the second one as well. So let's use 2x minus y equals negative 8. So 2 times x, which is negative 2, minus y equals negative 8. That's negative 4 minus y equals negative 8. Okay, so add 4 to both sides. Negative y equals negative 4. Divide by negative 1, y is going to be 4. So the solution right here, our answer, is the ordered triple, negative 2, comma 4, comma 6. Now let's check. You can check it by plugging any of the variables into any of the equations, all 3 equations, to verify them. I found y using the top equations. I'm just going to check y using the bottom equation. The y value we found was 4, and the z value was 6, so 4 plus 3 times 6. And I want to see if that's equal to 22. So 4 plus 18 is 22. So in that equation it checks. We should check in all 3 equations to be sure, but I verified at least the y value by checking in that equation. Next we have an application of 3 variable systems. If I want to find the equation of a parabola, I need 3 points, and the 3 points all must satisfy the equation y equals ax squared plus bx plus c, the standard equation for a parabola. If I don't know what the parabola is going to be, that means I don't know what the values of a, b, and c are going to be, but I do have a set of x and y values. So we're going to plug those in. So y, which is 9, equals a times 1 squared plus b times 1 plus c. That turns into the equation 9 equals a plus b plus c. Okay, let's do another one. The ordered pair 7 is the y value, equals a times 2 squared plus b times 2 plus c. We're plugging the x value into x squared and x. Okay, so if I simplify, this would give me 7 equals 4a plus 2b plus c. And third, the y value is negative 15, so negative 15 equals a times 4 squared plus b times 4 plus c. So it would be negative 15 equals 16a plus 4b plus c. Okay. So to write the equation for this parabola, we need to solve for a, b, and c. We're going to be solving this system. The easiest variable to eliminate is going to be c, since the coefficient of c is 1 in all of these. So let's go ahead and multiply the top equation by negative 1 and eliminate c. If I multiply the top equation by negative 1, we're going to get negative 9 equals negative a minus b minus c. Let's add that to the second equation. 7 equals 4a plus 2b plus c. If I add those up, I get negative 2 equals 3a plus b, and the c's eliminate. I'm going to do the same thing. I'm going to add negative 9 equals negative a minus b minus c to the last equation, which is negative 15 equals 16a plus 4b plus c. If I add these up, we're going to get negative 24 equals 15a plus 3b, and the c's eliminate. We've eliminated c in both equations, so now we have 2 equations in terms of a and b. Notice that the coefficients of a are 3 and 15, so I can make those both 15 by multiplying by 3, or 1 and 3, and I can make those both 3 by multiplying by 3. We're going to choose the smaller value. So we're going to multiply this by 3, actually a negative 3 to eliminate right there. So this will be 6 equals negative 9a minus 3b, plus the other equation is negative 24 equals 15a plus 3b. The 3b and the negative 3b eliminate. I have negative 24 plus 6 is negative 18 equals 15 minus 9 is 6a. And if I divide both sides by 6, we're going to get our value of a. So our value of a is negative 3. Now that I have the value of a, I want to use one of the equations that only has a and b, so I need to use one of the ones I found here in blue. Let's go go ahead and use the first one. So we're going to use negative 2 equals 3 times negative 3 plus b. Negative 2 equals negative 9 plus b. And if you add 9 to both sides, you're going to find that your b value is 7. Okay. Last, I need the value of c. Use any of the equations that have a, b, and c. Let's go ahead and use the top one. 9 equals a plus b plus c. If 9 equals a plus b plus c, 9 equals negative 3 plus 7 plus c. So 9 equals 4 plus c, and if I subtract 4 from both sides, I'm going to find that c has to be equal to 5. Okay, I know the values of a, b, and c. So now we're going to be able to write the quadratic equation that passes through those 3 points. The quadratic equation is going to be y equals, it was a, that's negative 3, x squared, plus b, that's 7x, plus c. So this quadratic equation is the quadratic equation that contains the 3 points, 1, 9, 2, 7, and 4, negative 15. You could check out by plugging the x values in and verifying that you get the correct y value. That's it for this section.